Have you noticed that the heat in recent years feels unusually intense? This isn't merely an illusion. According to the latest reports from the WMO, there's an 80% chance that we will set new high-temperature records within the next 5 years. In other words, it could get hotter. We've seen airport runways cracking from the heat, and even the Eiffel Tower has tilted by 20 centimeters due to rising temperatures. Meanwhile, in the Arctic, temperatures are rising at 3.5 times the global average. But as we worry about the Earth potentially becoming a second Venus, here's a more mind-bending scientific fact. We are currently living in a long ice age, specifically a relatively warm interglacial period. So, when will the next ice age arrive? To uncover the answer, we must journey back millions of years to feel the pulse of Earth's climate and seek the answers. Here, we will witness a majestic and decisive era that shaped the future of life on Earth and left behind some of the most thrilling remnants. This is the last ice age. This exploration will let you experience the extreme environments Earth's life forms had to endure. Around 100,000 years ago, many of Earth's ecosystems were reshaped by massive ice sheets, piercing polar winds, and barren landscapes. This was a frigid glacial period that lasted for thousands of years. As this era ended, many iconic species mysteriously vanished, and the reasons behind this still haunt us. What you are experiencing now is not the first ice age. In fact, Earth has undergone 5 major ice ages. What do they have in common? An ice age is characterized by prolonged periods of extreme cold, lasting millions or even tens of millions of years, causing large portions of the Earth's surface to be covered by ice sheets. The last ice age began approximately 2.6 million years ago, during the Pleistocene epoch. You may be surprised to learn that we are still technically in this period. Every ice age features 2 distinct phases: the cold glacial periods and the warmer interglacial periods. In fact, we are currently in the latest interglacial period, which has lasted for about 11,000 years. So when people refer to the last ice age, they often mean the last glacial maximum, which occurred before our current interglacial period, lasting from about 115,000 years ago to 11,700 years ago. Here's another intriguing fact. During the last glacial maximum, global average temperatures were only about 6 degrees Celsius lower than today. However, even a small change in temperature has far-reaching consequences. A 6-degree global cooling means a significant loss of heat from all oceans, land, and the atmosphere. During this period, most of Europe and North America were dominated by 2 massive ice sheets: the Laurentide ice sheet and the Fennoscandian ice sheet. The Earth's limited water was locked in these ice sheets, resulting in much lower average sea levels. The land was mostly covered in tundra vegetation spread across dry grasslands. No single factor can fully explain why the Earth fell into this severe cold, but examining the Earth's orbital patterns can shed light on many questions. In the last century, Serbian scientist Milankovic proposed a hypothesis. Long-term changes in Earth's position are powerful drivers of climate, which can explain how ice ages are initiated. Milankovic studied 3 types of movements that alter solar radiation: eccentricity of orbit, axial tilt, and precession of the axis. The eccentricity of the orbit refers to the shape of Earth's orbit, which becomes more elliptical due to stronger gravitational pulls from Jupiter and Saturn. This cycle of about 100,000 years means that when the orbit is highly elliptical, seasonal differences become more pronounced, with summers longer than winters. When Earth is at its aphelion, farthest from the Sun, in July, solar radiation is about 23% less than in January, resulting in milder winters and cooler, longer summers. The axial tilt, or the angle of Earth's rotational axis, also plays a role. The greater the tilt, the more extreme the seasonal changes. This cycle lasts about 41,000 years. So when the tilt is small, seasonal differences are mild, allowing summer temperatures to fail to melt winter ice. leading to ice accumulation and ultimately an ice age. Lastly, precession refers to the wobbling of the axis, due to the gravitational pulls of the Sun and Moon, creating a slight outward bulge at the equator, meaning Earth is not a perfect sphere. This movement has a periodicity of about 26,000 years, affecting the contrast of seasons, and either exaggerating or moderating seasonal differences. The combination of these three cycles significantly impacts Earth's long-term climate, and is a reliable factor in predicting major ice ages. However, shorter-term cycles are also crucial, as they can either amplify or lessen these effects. Events like the Danskar-Doshker events, associated with sudden warming, and Heinrich events causing rapid cooling, have influenced the last glacial period. Now let's address a key question. How did the creatures roaming our planet at that time adapt to these changes? What did they look like, and how did they live? Most of the last glacial maximum occurred during the Pleistocene, from 2.6 million years ago to about 11,700 years ago. The Ice Age was an era dominated by giant animals. Giant is no exaggeration, with some weighing as much as 4,500 kilograms. Why did everything in the Ice Age trend towards enormity? Several theories exist, one being Bergmann's rule, which states that larger-bodied endothermic animals, like mammals, tend to thrive in colder environments. Larger body sizes reduce the surface area to volume ratio, helping them conserve heat. This might partially explain why so many awe-inspiring large species evolved during the Ice Age. Let's start with the most famous of them all, the woolly mammoth. For many, the woolly mammoth symbolizes the Ice Age, a towering figure walking through immense snowdrifts, seemingly unfazed by the cold. But the reality may be a bit different. Woolly mammoths were not significantly larger than modern elephants. Skeletal measurements indicate they stood about 3.5 meters tall, while some male African elephants today reach heights of 4 meters. Despite their similar heights, they had crucial differences. Woolly mammoths possessed a thick, warm double coat, with long outer hair and a dense underfur. Their body proportions were also different, being longer with shorter legs, which paleontologists believe helped them graze, without needing to bend down excessively. Additionally, they had a thick layer of fat, up to 9 centimeters for insulation, and small ears covered in fur to prevent heat loss. While we have strived to revive them, woolly mammoths ultimately went extinct. However, they did not disappear all at once. It's now acknowledged that a population of woolly mammoths, estimated to be between 500 and 1,000 individuals, survived on Wrangel Island until around 4,000 years ago, 1,000 years after the Great Pyramid of Giza was built. Next, let me introduce a more peculiar species, the Glyptodon. Their name means carved teeth, due to their broad, grooved teeth well-suited for grinding tough vegetation. They were large, heavy creatures, weighing up to 2 tons, traversing the Americas on elephant-like legs. Their bodies were protected by a massive shell, resembling that of a turtle, making them look like distant relatives of armadillos. However, they couldn't curl into a defensive ball. At first glance, you might think they moved slowly, but recent studies suggest they carried most of their weight on their hind legs, and might have even stood on 2 feet, offering a crazed image of a glyptodon, possibly using its armored tail for attacks, or reaching for food high above. Another surprising species that had relatives still around today is the giant ground sloth. During the late Pleistocene, there were 4 families, 27 genera, and an unknown number of species wandering the Americas. Over time, ground sloths increased in size, leading to the emergence of the massive Megatherium, which had features combining the height of a giraffe and the bulk of an elephant. The first known ground sloth fossil, the Megatherium, is estimated to have weighed around 3,800 kilograms. Compared to their ancestors, modern sloths seem minuscule, considering the average weight of these giants was between 800 and 1,200 kilograms. The digging behavior of these enormous creatures hints at the survival pressures they faced during their time. Some scientists speculate that ground sloths burrowed underground for warmth or to escape the heat during hot months, while others believe they did so to avoid predators. What kind of predator would dare to hunt them? Likely candidates include saber-toothed cats or giant short-faced bears. As you witness these massive, resilient creatures bravely facing extreme weather and colossal predators, you anticipate their survival into the next geological epoch. However, that's not how the story unfolded. At the end of the Pleistocene, these species vanished with little warning. In Australia and the Americas, a staggering 72% to 88% of large species went extinct. How did this happen? This question has sparked intense debate for nearly a century. Some argue that natural climate changes were to blame. With the arrival of interglacial periods, sea levels rose, cutting off land bridges and melting the ice caps that were crucial for species migration. However, this explanation isn't perfect, as woolly mammoths in places like Wrangel Island survived long after this transition. Another major theory, first proposed in the 1960s, directs our focus to human activity. At this time, you will encounter a historic moment. Your first glance at our ancestors, Homo sapiens, emerging around 300,000 years ago. They migrated from Africa and began colonizing other parts of the globe. This means they coexisted with other species during the Pleistocene and shared their habitat. Paleontologists have begun to ponder whether we, as humans, bear some responsibility for the extinction of these colossal creatures. Could we truly challenge and overcome mighty beings like the woolly mammoth and giant ground sloth? Although Homo sapiens evolved about 300,000 years ago, they did not experience significant cultural development until the Upper Paleolithic, approximately 50,000 years ago. At this point, hunting and gathering cultures reached their peak. We began using diverse tools and creating decorative items like pendants, while expanding our efforts beyond mere survival. Cave art became a form of self-expression, with many images from this period still visible today. In the Upper Paleolithic era, rapid improvements in tool technology significantly enhanced hunting capabilities. A brave Homo sapiens alone against a woolly mammoth might not fare well. But what if they teamed up in groups, armed with sharp spears capable of being thrown up to 40 meters? They created a fairer competition. One proficient hunting group was the Clovis people, ancestors of Native Americans, distinguished by their uniquely shaped Clovis projectile points. A point of contention arises here. Within a few thousand years of the Clovis people arriving in North America, giant animals went extinct. Therefore, we must question whether their intensive hunting practices contributed to the collapse of animal populations. Recent research analyzed the remains of a Clovis individual, known as Anzac child, finding that woolly mammoths made up about 40% of the protein in the diet of the child's mother, providing theoretical support for the idea that Clovis people contributed to the extinction of these megafauna. This leads us to question our next steps and maintain a sense of caution about Homo sapiens' actions. In Australia, a similar scenario unfolded. Just before and after humans settled there, Australia lost 85% of its large species. Paleontologists inferred the decline of large animals by measuring spores, discovering that giant animal populations collapsed within 4,000 years of human arrival. While environmental factors were changing, it's likely that human presence acted as the final straw. During the late Pleistocene, another mysteriously vanished species was the Neanderthals, who disappeared around 40,000 years ago. Neanderthals were among the first humans to survive in the cold glacial ecosystems. They exhibited strong adaptability, with a robust physique, large noses, and high nasal bridges to help them breathe humid air. Similar to woolly mammoth adaptations, Neanderthals had complex cultures and numerous skills. So, how did they meet their end? You may have guessed it, we might be partly responsible. Some paleontologists believe that Homo sapiens outcompete them, or they were absorbed into larger Homo sapiens populations. In fact, most people of Eurasian descent share 1% to 2% of their DNA with Neanderthals, supporting this latter theory. Although Neanderthals might have been the losers in this narrative, the unfair characterization of them as brutish and primitive fails to acknowledge their complex culture, language, and tools. Undoubtedly, the last ice age sparked significant developments, forever changing Earth's history. This is what you are witnessing now. Despite the uncertainties of this era, many species thrived, flourishing in both ice and interglacial periods. As your thoughts drift from the ice age back to the present, you may find yourself deeply impressed by the life diversity of that time. While most of those beings now exist only as historical remnants, their skeletal remains and burial sites continue to ignite our curiosity, hinting at a world where, at least for a while, humans coexisted alongside towering giants, navigating a primal wilderness together. But perhaps a more pressing question emerges. Will this occur again? Are we still within an ice age? And is the next glacial period approaching? We mentioned Heinrich events, occurring roughly every 10,000 years, leading to cooling. These events are marked by the release of substantial ice into the ocean. Recent data shows that ocean warming typically precedes these events, destabilizing ice sheets. We are currently observing these signs, which could be alarming indications of impending Heinrich events. If they do occur, they may trigger another cooling event, capable of ushering in a new ice age. So, when will the next ice age arrive? Perhaps the answer is no longer dictated exclusively by Milankovitch cycles. While we worry about glaciers returning, the warming driven by human activity acts like an invisible hand, pushing that timeline into unknown territory. If we do experience another ice age, we can only wonder which species will survive. Will Homo sapiens endure in another era ruled by ice and snow? Or will we too face extinction at the hands of better adapted species? As we ponder this distant future, what might Earth become? And who will inhabit it?